So these are the irons I will compare. First one is a Vela PU81 with the WSP80 handle and a rather large tip. The second one is my do-it-yourself soldering station with a rather small tip and a much bigger tip. For bigger joints I use it. Then we have those temperature controlled soldering irons from CXG, and we have the, can you see it? Oh, that fell down. The 936d rated 60 watt, and this one, this is the E90WT, and they have also rather narrow tips here, like this. And this is my test setup. I have a watt meter which displays the power line power that the soldering irons need, and I have a rather large copper sheet metal plate which is tinned at this edge, and I will hold the soldering irons onto that edge and see how much energy they can dump into this sheet metal. And many soldering iron reviews actually do not take this power into consideration, and they kind of only show you the iron, show you the display, it works, yeah, very nice, and it actually heats up the tip, also very nice, but the actual quality you want to have in the soldering iron is to dump as much energy as possible into a soldering joint. And there are two factors which are important here. One is the thermal mass or the thermal capacity of the soldering tip, because if you store a lot of energy in a rather large tip, then the moment you touch the joint, a lot of energy can flow into it. But the temperature of the tip must be sustained by the heating element, so that is the second quality that is there. How much energy can the heating core supply? And this is the actually much more important factor, because as you can see, this is a Vela tip which is rather small, and here in comparison I have a Hakko tip which works like a sleeve that goes around the heating core, while this one has a little surface at the back that is pressed against another heated surface. So obviously this one has much more thermal capacity than the smaller one, but still, as you will be able to see in the coming test, this smaller tip is actually able to provide more power to the soldering joint, as the overall design of the Vela is just superior. So at first let's take the Vela. I will switch it on now. So it's rated 80 watt and it's a bit over this power, so that's a good sign to start with. And it also heated up pretty quick and a pretty low standby power. Now add a bit of tin. And yeah, that's good. The full rated power goes into the solder joint. No, not anymore, but can heat up the edge here, not completely, but it's continuously around 50 watts. So we can say that on a hot solder joint, which is not quite up to temperature, it's still able to dump 50 watt in it, which is really okay. So the second is my Hakko 907 with a rather narrow K-tip. I will now switch it on, and there it goes. These are rated 60 watt, but that would be on the full 24 volt. And as my power supply cannot sustain the initial current, I put in a current limiting device, which, well, limits the current and thus the power. I can now try to switch to full voltage, and there you have it, over 60, almost 70 watt right now. I will continue in this setting, so it's powered by 24 volts now, with a current limiting device overridden. So this is a bit more standby current, standby power, and you have to remember that the power supply I use is not 100% efficient, so we have about 10% less power actually reaching the iron electrically than displayed here. So I will start now, tuning the tip and then holding it down. On 36, 38 even, but it has difficulties melting the whole solder here, so you don't even get full contact here. Yeah, but as I told, this tip is a rather narrow tip. It's not optimized to transfer a lot of thermal energy. It's for rather fine soldering joints. So it's well possible that the heating core could output more thermal energy, but the tip just can't transfer it off as well. Yeah, subtracting the 10% power loss I spoke of earlier, we can say that this iron can provide about 30 watt. So it's a fairly identical Hakko 907 now, but with a much bigger tip. And let's see how this one compares. Again, switch the station on with the current limiter in place. And as soon as the iron has heated up to about 200 degrees, I can switch over to full voltage. Yeah, because with the current limiter it's heating up fairly slowly. Try to switch over now. And there we are, 80 watt. Oh, it's heating up quick. And there we are. Oh, there we see it, much more power. So this is heating up things a bit better, but not quite as good as the Vela. But still you can see the identical system, just with a bigger tip, can put more energy into the joint. So again, taking the power supply's efficiency into account, I would say this one provides 40 watt output. Yep. So what I have here now is the CXG 936d, rated 60 watt, also with a narrow tip, but as you can see not quite as narrow as the K-tip I had before. So now I will switch it on. 335, as you can see, over 80 watt. That's a really good starting power. And now the final temperature is reached. So here practically all the electrical energy is going into heating without any efficiency losses, so we can take the display power at face value. It's having a hard time even reaching 30 watts. Alright, so the value is fluctuating a little, but I think we can say it's 28 watt as a mean value. Alright, yeah, so this one has about 28 watt maximum output under these conditions. So the last iron to test is the relatively new CXG E90WT. It has a nice display. I'll switch it on for you. 325. And heating up, it doesn't use as much power as the other CXG, but it's rated at 90 watt, and I think it approaches 70, but not much more. So 70 out of 90 from the cold, that's not too impressive, but let's see what it actually does when soldering. Again, rather thin tip. Yeah, this is again looking better than the other CXG. It's almost continuously staying above 30 watt. So we would say the mean value is about 30 to 31. And as such, it is a little better than the other CXG, although it didn't have as much starting power. But this one is pretty solid 30 watt, not always. But it was in the beginning, so we can say that this one dumps about 30 watt into a solder joint that has a little temperature.